Okay, this is on page 9 in your journal. We're going to do a little review, and then we are going to talk about manipulating some rational numbers in order to prove that they're rational. So rational numbers, okay, that's a little review from our first day on page 1, is any number that can be expressed as part of a whole, okay, and then in the form of a fraction or decimal. All right, so fraction is what we're really going to focus on during this part of our lesson. So whole numbers, if you'll remember, are going to be 0 and then your positive counting numbers. So like 0, 1, 2, 3, and so forth. Okay, then you have your integers. So this integer circle has the whole number circle inside of it. So that means integers are all of the whole numbers and their opposites. So all of the opposites, those negative opposites that are opposite of the whole number. So you've got all of the whole numbers, those are integers because the circle is inside of here. And then you've got all of their opposites. And then you have rational numbers, which is any number. So that includes all the whole numbers and all the integers. Okay, so this is rational. So it includes any numbers that can be written in A over B format. So that means fraction format. All right, so let's talk about how are we going to write all of these types of rational numbers as a fraction. So we're going to prove that they're rational and that they can be written in this format by writing it as a proper fraction, which is like 1/2 or 1/8 or 3/4, or an improper fraction, which is 6 over 4, or 3/2, or 8 over 6. So those are improper fractions. So if we just have a whole number 8, how would we make that a rational number? How would we prove it? By writing it as a fraction. So since this is more than one whole, right? So an improper fraction is going to be more than one whole, and a proper fraction is going to be less than one whole. All right? So an improper fraction is going to be more than one whole. So 8, of course, is more than 1. So we're going to just put it over 1. And we're going to write that in A over B format, which is in improper fraction format. All right, and so you just proved that 8 was a rational number because you could write it as a fraction. -4 is going to be just like this. We're going to put it over 1 because dividing it by 1 doesn't change the value of -4. So -4 over 1, that's how we would prove that and write it in fraction form. This right here, we are going to mad pop it. Okay, Miss Sanders, she mad pops it. So if you mad pop it, that's going to be multiplication, addition, and then you're going to write it with the same denominator. So we're going to multiply. 4 times 2 is 8. 8 plus 1 is 9. And then we're going to keep the same bottom denominator. So 2 1/4 of pizza is the same thing as 9/4 of a pizza. And now you've written it in A over B format to prove that it is a rational number. And there's lots of reasons why we do this. When we get into multiplying and dividing fractions, we're going to be doing this manipulation of these numbers all the time. So this is just a little review for that. So here we're going to read this like a mathematician, okay? We're going to say, all right, we're going to put the 1 under the decimal like we were taught in 4th grade, and that helps us read this like a mathematician. So we're going to say 6/10, and we're going to write exactly what comes out of our mouth as a fraction, 6/10. We'll worry about simplifying that later. Here we're going to do the same thing. We're going to put our 1 under our decimal and put a 0 under our 7. So now that's going to be -1, there's my whole number, and 7/10. I'm going to write that as a fraction. And then I'm going to do the same thing that I did here because I want it as a fraction, and this technically is a mixed number because it's mixed because it has a whole number and a fraction. So we're going to Matplotlib, and we're going to say 10 times 1 is 10, and 10 plus 7 is 17. Keep my denominator, and don't forget my negative sign that was out here. And that decimal becomes that as a fraction. So these are all equivalent to each other. So we're going to place each number on the Venn diagram in the most specific spot possible. So the most inner circle possible. So we've got our whole number. 8's going to go here. -4, that's going to be an integer. 2 1/4, that's going to be irrational because it's part of a whole. Our decimal, because it's part of a whole, is going to be just rational. And then we've got this one that is just rational. It's not an integer and it's not a whole number. All right, on this, we're going to, which number in the diagram is in the wrong category? So 1, 2, 3, 0, those all look good. This is definitely not a whole number. It's not opposite of a whole number. So it's definitely going to go out here. -8, -29, those look good. This right here is part of a whole. If it was just -2, we would leave it, but it's -2 4/10, so that's going to go out here. So which number was in the wrong spot? It was going to be this one right here. Which statement best explains where 7/8 is placed? Well, 7/8 was not in the right place, so it says it's correct. Well, that's not true. It's incorrect because 7/8 is a fraction, not a whole number. Well, that's true. It is correct. No, it's not. It is incorrect because 7/8 equals 1.2, and 1.2 is not a whole number. Well, we'll talk about it a little bit later, but 7 divided by 8 is not going to be 1.2. 8 goes into 7 0 times, and so even before I start, I know my whole number is 0 right here. So I know that this is incorrect.